Good morning, students. Very good morning. Last class we discussed the introduction of, that is chapter 10, debugging programs. And last class we discussed the definition of debugging, what is meant by debugging, and what is meant by error and different types of errors. Okay. Today we will discuss, in this class we will discuss the examples for different types of errors. Means that is logical errors, syntactical errors, semantic errors, and runtime errors. So all these topics we discussed in this today's class. So coming to, all these types of errors, we give some examples: syntax errors, semantic errors. Okay, Python programming code, we follow some rules and regulations. Okay, we follow some rules and regulations. Suppose I write one code here. Okay, if x is less than y, I write here print x is small, x is lesser than y. I print this, s is less than y. This is the code I write here. Okay. This statement, this is a Python code. Here we miss some. Okay, when we are executing, it returns some errors. Why? Because here we write with syntax, means grammatical errors. We follow here some grammatical errors. Every Python programming having one if condition, after the condition we place here some colon, but here not writing here any colon. So that is one mistake. Here one mistake, that is one error. This type of errors are called as syntax errors. Compulsory we place here colon. So that is one mistake. So it depicts in this line consists of some error in the compilation process. So that's why it is calling it as compile time error. So syntax errors are called as compile time errors. Okay. So here, okay, after if condition colon, we maintain some indentation. But we have not maintained any indentation. That is grammatical mistake. This one is one type of syntax error. That's why here this one is also one of the error. This one is first error, this one is second error. So after rectifying this code, we write the original code without any errors. So first we write if x is less than y colon, we maintain here some indentation. You know very well what is meant by indentation. Okay. See here, write print x is lesser than y. X is lesser than y. So here double quotes. We place single quotes or double quotes. Okay. We must and should use print statements. Okay. Use here x is less prints or it displays x is less than or lesser than y. So these type of errors are called as syntax errors. Understood my point? So next, coming to next example, I write here two statements. One is x is assigned y star z. X is assigned y star z. Second statement is if x is equal to x star y. Here first statement, this one is first statement, this one is second statement. So when we observe this first statement, here this one is our intention is assignment. X is assigned y star z. First we calculate y star z and assign to the variable x. But here we use this arrow symbol. It is not an assignment operator. So this assignment symbol is used in algorithm. When you are writing algorithms, we use this symbol. Here This one is syntax error. Here we fix these errors in compile time process. Okay, and rectify these errors. We replace this arrow mark symbol, means assignment symbol. We use this symbol in algorithms, not in Python programming language. That's why we replaced in Python programming language assignment symbol. So first we calculate y star z. After this value calculate this value is assigned to the variable x. This is the syntax and semantics of this statement in Python programming language. Like that, when we observe the second statement, here we compare these two statements, x and x star y. But here we use only single s equal to symbol. Okay, we compare these two expressions. So compare, here we use comparison operator, equal to, double equal to, but we write here only single equal to. This is one type of error. So this error is called as syntax error. According to syntax, okay, we use here double equal to symbol, but here we use only single equal to. Single equal to means in Python programming language, single equal to means it is an assignment operator. That's why it is displays some error. We use here double equal to symbol. So this is the one type of compile time error. So this is the concept of syntax errors. Examples for semantic errors. I write here, okay, x is, okay, I write here z is assigned to x star y. I write one statement here, z is assigned to x star y. Z is assigned to x star y. Otherwise, the statement x star y is assigned to z. Here, when we observe this statement in Python programming language, okay, here the meaning of this assignment operator is correct. Here, syntactically it is correct. Syntactical. Why? Because every assignment operator having left hand side and right hand side. So this expression having left hand side and right hand side. So here syntactically it is true. Syntactically it is true. But when we observe this statement semantically, semantic means meaning. Okay, we provide some meaning to every statement in programming language. So the meaning of this statement is, okay, we assign the value to x star y, but one single value is not assigned to expression in assignment statement. Okay, this is error. We rectify this error. Actually, we write here, okay, z is assigned x star y. So one single variable not assigned to one expression. So that is the, here syntactically it is true, but semantically it is false. This type of errors are called as semantic errors. Understood my point? Coming to runtime errors. Very dangerous errors, already discussed. These errors are very dangerous. Why? Because for this type of errors, the system, in some cases, the system crashes or abnormally halt the entire program because of this runtime errors. One variable. First we initially define the variable. After define the variable, we use that variable in our programming language. So without defining the variable we use in programming language, it returns some error. That error is called as runtime error. Writing loops. Okay, when you are writing loops, we write condition, loop ending condition. Okay, so we correctly define that condition, otherwise it enters into infinite loop. So infinite loop occurs because of this runtime errors. Why? Because we not define the error properly. So those errors are called infinite loops. Infinite. So loop, when we are using infinite loops are one of the means one loop not terminated in one such condition. Those loops are called as infinite loops. So they execute infinitely without any break. Those errors are called as, those errors are occurred during the runtime errors. So these errors are not depicted in compile time process. That's why these are called as runtime errors. Coming to next. Otherwise, next one more important. Okay. So in one variable, first we define the variable data type. So when we enter any input, suppose I place here one integer data type, one variable x. We define that variable as an integer data type, but we are supplying different data type for that variable. Those errors are called as runtime errors. So these errors create problems when you are executing or running the program. So infinite loops, without defining the variable, we use those variables in our programming and we supply different data type for that given input. These are comes under the type of runtime errors. Next, coming to logical errors. These are all runtime errors. Coming to logical errors. So third type of errors, logical errors. So logical errors means, suppose I write here sum of two numbers. Actually my intention is sum of two numbers. I take a is equal to 10, b is equal to 20. I calculate c is equal to, actually my intention is sum of two numbers, a plus b. My intention is to calculate a plus b, but I write here in place of plus I write here star. Okay. See, print c. Okay, my intention is sum of two numbers. It displays actual output here, expected output. This one is expected output is 30. Why? Because 10 plus 20 is 30. But required expected output, achieved output, achieved here when you are executing this program or code, it depicts this value, that is 200. See, when we observe this expected output here, achieved output, both are different. Why? Because here my intention is to summation of these two, 10 plus 20 is assigned to the variable c and display that variable the value of c, 30. But here I write here, I replace plus with another arithmetic operator star. This is mistake, programmer's mistake. So these logical errors are occurred because of programmer's mistakes. Okay. So when we observe every statement thoroughly, this type of errors easily rectified and fix this error. Here it doesn't display any error. Why? Because here it calculates, our intention is 30, but it displays 200. It doesn't display any error. Why? Because here it calculates 10 into 20. Why? Because here we write star in place of plus. That's why it calculates multiplication 200 and display the, store this value in C. Finally it displays the, print the value of C, that is 200. So here no mistakes are there, but our expected output is 30, but it doesn't display the value 30 here. It displays the value 200. Why? Because without giving any error, it displays another value. So this one is also one of the error. This type of errors are called as logical errors. So first we scan each and every statement of this code, then we rectify or change this value, plus again compile this code and execute this code So it displays the expected output is 30 and achieved output is 30. So this type of errors are called as. Here algorithmically we write here actually plus, but according to our programmer's mistake, in place of plus we write here star. That's why it returns 200. So we change that star with the plus, then it displays the correct value. So this is the concept of logical errors. Up to now we discussed the concepts of errors and different types of errors. So coming to next topic is exception. I already explained as class, errors and exceptions are both different but similar in nature. Both are errors but similar in nature, but there are some differences there. So we explain the concept of what is meant by exception and how to handle the exception when you are having any this type of errors when you are executing this program. So exception and exception handling concepts we discussed in this class. Okay, what is meant by exception? Okay, so an exception is a trappable error. An exception is a trappable error. So an exception refers to any irregular situation that are occurred during the execution or runtime of the program. Okay, see, it is a irregular situation. We not expect that situation. In some cases, this type of errors creates problems. Okay, so to handle this type of errors means exceptions. Okay, we implement the exception handling. It is one of the important topic in programming languages. Okay, exception handling is one of the topic in every programming language, that is C, C++, Java, like in our Python also. Okay, so exception is a irregular situation. So error means it is a bug. Okay, when you are executing any compile time or runtime, we are undergo this situation. Some cases errors are occurred. So those errors can be fixed. How to fix those errors? So those mistakes can be overcome. To rectify those errors, runtime errors and syntactical, semantical and logical errors. But these are different in nature. Exceptions are different in nature. How to differentiate exceptions with errors? See, I take one example, explain one real-time example, that is ATM machine. See, when we go to ATM machine, first we enter our account number, either account number or PIN. Suppose we enter our account number or PIN. So if any mistakes that are occurred when you are typing the PIN number or that is password or account number, that is the concept of comes under the case of error, that is called as error. Suppose if you are trying to withdraw some amount, in that situation your account balance doesn't exist in a proper way, means it has insufficient balance in your account. In that situation it displays some message. So you have insufficient balance in your account. So that is the case that displays one message. This type of errors are called as exceptions. Suppose that message not displayed when you withdraw from insufficient balance. So it creates problems. If that message not displayed in your ATM machine, immediately the user or account holder, okay, face some problems. Why the amount not getting from this ATM machine? So we think the reason why the withdrawn amount not coming from the ATM machine. So that's why in this case they display this type of errors, exception, so trackable. So in that case, okay, it displays one message. Displays that message is calling it as you have to maintain insufficient balance. That's why. So immediately the account holder, okay, understand this situation, and he knows that balance amount not sufficient in that particular account. So immediately he knows everything. So that is the case, that is the difference between error and exception. Okay, so to handle this type of situations, exception handling mechanism we implement in programming languages, exception handling mechanism. Coming to exception is a trappable error. It is an irregular situation when you are executing a program. Okay, so coming to exception handling, to handle the exceptions we use exception handling mechanism in any programming language, especially in object oriented programming languages. So in Python we control this exceptions by using this try and except clauses. Okay, so this one is one routine. Routine means one method, like a functionality. It provides some functionality. So try and except. See, observe this try is a class keyword and except is a class. These two clauses handles this exceptions in Python programming languages. Here we write the code that may generate an exception. So here in this code we write here some code. Okay, in this code having any exception, immediately one exception raised, immediately control goes to how to handle, how to rectify these exceptions. Okay, that code is placed in this block. These are two blocks, try block and except block. In some other programming languages, except block, try catch. In Java, C++, all these are having try catch. But in our Python language we use try except. So try block, except block. So try block consists of some code. In that code may generate an exception. If an exception raised, immediately it comes to this except block. How to handle, how to rectify this exception in Python programming. The code is present here. That's why we write some code here about what to be the exception has occurred. Here handling of that exception can be handled in this code. Okay, this is the general syntax of exception handling in Python. Coming to example for try except block, that is exception handling example. How to handle exceptions in Python through example. See, I write here some code, try block having some code, two statements, two print statements are there. Here except block consists of one print statement. So when we are executing this program, this try block having two statements, so it displays two statements. First one is result of 10 by 5. It calculates the result of 10 by 5. So when we are executing this program, first it displays, executes this try block. So execution starts from this try block. So first execute this, display this statement. This statement consists of results of 10 by 5. It displays the result of 10 by 5 is equal to 10 by 5. 10 by 5 means? 10 by 5 means. So 5 is cancelled in 10. It returns 2. So the final answer is 2. That's why it returns result of 10 by 5 is equal to 2. Coming to next print statement. Okay. Next, result of 10 by 0. See, observe this. Result of 10 by 0 is 10 by 0. 10 by 0 means here we divide 10 with 0. It is invalid in mathematical statement. According to mathematics, we not divide any number with 0 is invalid statement. So that's why it returns some error. These errors are called as exception. This type of, so immediately this program halt and it rages. Suppose we write some except block. Immediately when we execute this print statement, result of 10 by 0, it raises one exception. Immediately control goes to this except block. From try block to except block. It handles this exception. Okay. Immediately comes to this except block and display this message. Divide by 0 error. It displays the message divide by 0 error. We not divide with 10 with 0. That is an exception. Immediately when exception raised, it comes to this except block. This except block can be executed one after the other. All the statements of the except block are executed one after the other. So here we write one print statement that can be displayed in our exception handling mechanism. So here we write divide by 0 error. It is an error, divide by 0. So what will happen here? Denominator must not be 0. So it says that denominator must not be 0. We will not divide any number with 0 is an error. That displays this message. That's why the output here display this output when you are executing this exception handling code. So if any errors are occurred during the runtime or execution time, immediately try block. So this try block having some code. When we execute this try block code, if any exceptions are occurred, immediately that next block, that is except block, catch this exception and execute this except block. This is calling it as one routine. Try except routine, that is exception handling routine. Okay, see, when we observe this output, first it display result of 10 by 5. It calculated value, that is 2. So the result of 10 by 5 is equal to 2. Next it displays when we execute this statement, okay, immediately it causes some exception. Immediately it comes to this statement, it displays divide by 0 error. Denominator must not be 0. It displays that message. We understand the actual problem or exception from this statement. Okay, in this way we handle exception in exception handling mechanism by using Python code. So thank you students. This is the today's class. Next class we discuss some more exception handling objects in Python. Thank you students.